This video is about logistic regression, which is used to predict the probability of binary outcomes. Here is a comparison between linear and logistic regression. Linear regression predicts continuous outcomes. It assumes a linear relationship between independent variables, which are also called as predictors, and dependent variables. The outcome of linear regression is continuous. An example would be predicting house prices. House prices is a continuous variable and therefore we use linear regression. Logistic regression, on the other hand, predicts the probability of binary outcomes 0 or 1, yes or no, or some sort of categorization. It uses a sigmoid function to model probabilities. Its outcome is binary outcomes. An example would be predicting customer purchase, whether a customer would make a purchase, yes or no. Here are some examples about the application of linear and logistic regression. Predicting a student's GPA based on study hour. GPA is a continuous variable and therefore linear regression will apply. Predicting whether a loan will be approved or not. This is categorization. There can be two outcomes. A loan will be approved or not approved, and therefore logistic regression will apply. Estimating house prices based on square footage. House price is a continuous variable, therefore linear regression will apply. Predicting if an email is spam or not, that's categorization, yes or no, therefore logistic regression will apply. Predicting weight based on height and age. Weight is a continuous variable and therefore linear regression will apply. Classifying a tumor as malignant or benign, that's categorization and logistic regression will apply. Forecasting a company's quarterly revenues. Revenues of a company is a continuous variable and therefore linear regression will apply. Predicting whether a customer will churn or not, that's categorization and therefore logistic regression will apply. Predicting test scores from number of hours studied. Test score is a continuous variable and therefore linear regression will apply. Finally, predicting if a person has diabetes, yes or no, that's categorization and therefore logistic regression will apply. Here is an example of the difference between linear and logistic regression. If a physician or a scientist wants to predict the size of tumor based on some predictors such as age, smoking, and lifestyle, linear regression can be used. This is the equation for linear regression, whereby we have intercept and then coefficient and first variable and second variable. First variable could be, for example, age. Second variable could be smoking, and other variable could be lifestyle or any other factors. And using linear regression, a physician or a scientist can make prediction about the size of tumor. However, sometimes physicians and scientists are more interested whether a tumor will metastasize or not. They are not interested in the size of tumor, but they want to know whether a tumor is it benign or malignant. And for that purpose, linear regression will not work. For this purpose, we convert this linear regression into probability and we use this formula. Probability is equal to 1 over 1 plus e raised to the power negative z, and that converts this linear prediction into probability from 0 to 1. Therefore, when the objective is to make a prediction about the size of tumor, linear regression will work. However, when the objective is to make a decision whether a tumor is benign or malignant, then logistic regression will be used. Logistic regression uses sigmoid curve. So for example, here we have a sigmoid curve, and on the x-axis we have tumor size and on y-axis we have malignancy. And 2 points are particularly important, 0 and 1. 0 means it doesn't metastasize, in other words it's benign, and 1 means it is malignant. And in between, this is a threshold value which is usually 50%. Anything less than 50% will be rounded to 0, which means the tumor will be benign, and anything above this threshold value will be rounded to 1, which means it is malignant. This sigmoid curve has 3 parts: this bottom part, this upper part, and the part in the middle. So for example, this bottom part, consider this point. At this point, the value of x is very, very low. Probability of malignancy is also very low. It's close to 0. This point has a little bit higher tumor size. Tumor size is increasing. So this point has relatively higher tumor size compared to this one. This one has higher tumor size compared to this one. But the chances of malignancy are very close to zero. At the top of the curve, tumor size is very high, and the chances of malignancy are also very high, and therefore it's close to 1, which means it's malignant. And then tumor size increases here, it further increases, and this point has the highest tumor size, and therefore the chances of malignancy are close to 1. And here is the middle part, which is very steep. This shows that small changes in tumor size can make a big change in the probability of malignancy. So for example, the difference in the size of this point, which is B9, and this point, it's not much, but the chances of malignancy are significantly increased. We will solve a problem using our program. So here's the problem. Calculate the probability of customer making purchases based on their age and income. So which mean age and income are independent variable, also called as predictor. Customer making a purchase or not making a purchase, that's the dependent variable. What is the probability that a customer with age 47 and income $94,000 will make a purchase? Consider threshold value is 50%. And these are our questions. Which type of regression analysis to use? Should we use linear regression or logistic regression? In this case, our dependent variable is customer making purchase. Two binary outcomes are possible, making a purchase or not making a purchase, and therefore logistic regression will be used for this purpose. Second question is develop a logistic regression model, and the third question is what's the probability for age 47 and income 94,000, and last, determine the goodness of model fit. And for this purpose I will use R program. This is the core code used for logistic regression. Logistic regression is equal to GLM, which stands for generalized linear model, dependent variable, first predictor plus second predictor, family is equal to binomial, and the name of data file. This is the R file containing all the codes. And the first step is to load the data, and for that purpose I will use this code. My file is equal to read.csv file.choose, and if I run this command, it will open a new dialog box from where I will choose my file. The next step is to attach that file. The name of my file is my file, which is containing my data, and in the next step I want to attach it. So I will use this code, attach my file. The third step is view my file. And this is optional. If you want to see how your data looks like, you can use this command. So if I run this code, it will show me how my data looks like. So this is our data. And over here you can see our first variable is age, which is a continuous variable. Income is also a continuous variable, and purchase is the dependent variable. Age and income are independent variables, also called as predictors, and purchase is the dependent variable. We have only two types of values, 0 and 1. 0 means no purchase and 1 means making purchase. This is the core code for logistic regression. GLM stands for generalized linear model purchase, which is a dependent variable followed by tilde sign, and first variable, which is age, plus second variable, which is income, and then family is binomial because we have two outcomes, and data is my file. This is the name of the file which is containing data. As you can see here, this is the file which is storing the data. So I will run this command, and all the results will be stored in this one, my model. And if you want to see what is there in it, I will use this code, summary my model. If I run it, it gives me these results. These results show, first of all, there's intercept, which is negative 5.845 times 10 raised to the power 1, which means this will be negative 58. And this is the coefficient for age, which is 1.09, and this is the coefficient for income, which is 1.202 times 10 raised to the power negative 4. So this is a very small amount. We will have to put 3 zeros before this one. So this one will be 0.0001202. So this is very small. And these are probability values. The probability of age is 0.0831 and 0.4020. Both are greater than 5% or 0.05, which mean they are not significant. This shows that the coefficient of age, which is 1.091, it shows that when age is increased by 1 unit, it increases the odds of purchase by 1.09. The coefficient of income is very small, 0.000102, and the p-values are greater than 5%, indicating a non-significant effect. In the next step, we want to make a prediction what would happen if a person has age 47 and income is 94,000, and make a prediction. And for that purpose, I will use this code, which is predict my model, data frame age is 47, income is 94,000, type is equal to response. And if I run this command, it gives us these results. It shows that the probability will be 98.42%. So the probability of purchase for the given age and income is 98.42%, which is greater than the standard threshold value of 50%, indicating that the individual will make purchase. The next step is to determine how good is our model, and for that purpose we use two methods. One is called as deviance, and deviance is of two types, null deviance and residual deviance, and the other one is Akaike Information Center or AIC. RStudio provides null deviance and residual deviance. Null deviance is the deviance of a model with only the intercept, no predictors or independent variable. Independent variables are considered constant, which is 1. And residual deviance is the deviance of our actual model. So for example, in this case, this is the code, the core code which is used for logistic regression. R calculates two types of deviance, null deviance and residual deviance. Residual deviance is the deviance of this model, which has our dependent variable, which is purchase, and independent variables including age and income. Null deviance is the deviance whereby these predictors, age and income, replaced by a constant, which is 1. So there are no more predictors, only dependent variable, and that is called as null deviance. And over here we can see null deviance is 33.6506 and residual deviance is 9.2728. We want lower deviance. The rule is that the deviance of a residual or fitted model should be less than the deviance of null model. So for example, in this case, residual deviance is 9.2728, which is less than the deviance of null model, which is 33.65. It means that the predictors which are included in our original model improving the model. For a good model, the residual deviance should be less than null deviance, indicating that the predictors improve the model's fit. The next criteria is Akaike Information Center or AIC. R has already calculated AIC value of 15.273. This is the AIC value of our fitted model. If we want to calculate AIC of null model, I will use this code, my model underscore null GLM, generalized linear model purchase, and then 1. Over here, the predictors age and income have been replaced by 1. Family is equal to binomial and data is equal to my file, and if I run this, that gives us AIC value of 35.65. So this is our null model, because in this model predictors have been replaced by a constant, which is 1. AIC value of our null model is 35.65, whereas AIC value of our residual model was 15.27. AIC value of our residual model is less than the AIC value of null model. AIC of residual model is 15.273 and AIC of null model is 35.651. This implies that according to this criteria, AIC, this model is a good model. When we started analyzing this problem, our objective was to determine which type of regression analysis would be suitable, whether a customer will make a purchase or not, which is a binary outcome. Therefore, we used logistic regression. Our second question was to develop a logistic regression model, and we developed this logistic regression. This whole model is called as logistic regression model, which includes intercept, coefficients of age, coefficients of income, income and their probability values and their deviance values and AIC values, all these things collectively are called as logistic regression model. Our third question was, what's the probability of purchase when age is 47 and income is 94,000? We made this prediction. It was 98.42% because this value is higher than the standard threshold value of 50%. Therefore, we conclude that the customer will make purchase. And our last question was goodness of model using residual and null deviance and AIC. Residual model is our fitted model, which includes our predictor variable. Null model is the one which excludes independent variables or predictors. Predictors are replaced with a constant which is 1, and then it calculates deviance. And the rule is that the deviance of a residual model should be less than the deviance of null model. And as we noted that the deviance of fitted model is less than the deviance of null model, which indicates that this model is a good model. Similarly, AIC of fitted model is less than the AIC of null model. All of these things indicate that this is a good model. Logistic regression is used to predict loan default using income, credit score, and employment history. So if someone wants to predict whether someone will default or not, logistic regression will be a good tool. In marketing, you want to forecast customer churn based on usage pattern, activity, and demographics. Logistic regression will be a useful tool. In healthcare, logistic regression is used to assess disease risk.